Okay, thanks everyone. Thank you so much for joining us today for our Minecraft education live lesson. And today we're going to look at Artemis Return to the Moon. So this is a live classroom workshop and we'll be presenting to you, and you are welcome to ask us questions as we go along. You're welcome to pause the video at any time. And we're going to try and make this really interactive and fun. And we've got some amazing guests today. So just before we start, I'd like to acknowledge the traditional owners of the land that I'm joining you from today, the land of the Whadjuk people of the Noongar Nation. And I pay my respect to their elders past and present. My name's Stephen Payne, and I'm going to be leading you through today's session. I work here in Western Australia, and I'm joined by Robert Burke over in Queensland. Do you want to say hi, Robert?
Good morning, everyone. I'm Robert Burke. I'm living over in Brisbane, so I work in Brisbane Catholic Education with the students in our sector as well. So welcome to anyone from Brisbane. I know most of you will be on holidays today, so hopefully everyone else has a good Easter break as well after we finish.
Thanks, Robert. And Robert's going to be leading us through some of the activities later on today. So first of all, I'd like to say a huge thank you to Minecraft Education, who have put these worlds together in consultation with NASA, who we're also going to hear from today. I think these are an amazing resource for students and teachers, and I think we're going to have a lot of fun today, but also learn a lot of great stuff as well. So I'd love to know where you're joining us from today. So if you have any questions about how the worlds work, or more importantly, if you want to find out from Jason, who's joining us today from NASA, what it's like to work at NASA, what goes into the Artemis missions, and he knows everything. So get your questions in and we will get those answered today. So feel free just to click the Q&A panel on the right hand side of your screen. You might want to leave that open so you can see what other people are asking. We can't see you. You can see us and you can see our screens, but we can't see you. So the way for you to communicate is to type your questions or comments, say where you're from, and we'll be able to answer those questions. You can also play or pause the event at any time. So if you've joined us late, you can just pause and rewind, and the videos will all be shared on the Minecraft Education YouTube channel after today as well. So hopefully you can work out how to use the controls, but if you've got any questions, put them in the Q&A. And remember, you can play or pause or skip to live whenever you need to. So thanks very much wherever you're joining us from. Across Australia and New Zealand, but also right across the world. I think we've got people joining us today. So thanks very much for joining in. I'd now like to introduce you to Jason Hutt, who works at NASA. So I'm just going to bring Jason into the screen and say, "G'day, Jason."
G'day. Good morning, everybody. It's great to talk with everybody.
So if it would be great just to find out a little bit about your role at NASA. That sounds like a really important role that you have there. So what does that actually mean day to day?
Okay, and so I'm coming to you from my home here in Houston, Texas, and I've been working at Johnson Space Center for about 24 years now. I moved over to the Orion program about 6 years ago, and where I'm at now, what that title means, Systems Engineering and Integration, my team is responsible for making sure that when we put our Orion spacecraft on top of the rocket, or when it's on the launch pad, we know that the rocket's going to work correctly with the spacecraft. When it's time for our spacecraft to dock with the lunar lander that'll land on the moon for the first time since 1972, that's going to work properly, and that we know that the astronauts can complete their mission and complete it safely when it comes time for us to return to exploring the surface of the moon.
That is fantastic. One thing that's just popped into my mind, why has it been so long, do you think, since, or do you know?
So it's a long and complicated story, and sometimes it amounts to we have different priorities and different directions that we had to go. So we wanted to establish, the ability to try to easily access low Earth orbit, and with the space shuttle, and then we've built the International Space Station, which has been a fantastic collaboration project from countries around the world. And then we only have a finite amount of money. So when we do these things, we have to prioritize. And now we've gotten to the point where we are able to make enough progress that we can return, and this time return to the moon to stay. And we have an architecture, a spacecraft, the rest of the systems that are in development that allow us to keep people on the moon for longer than what was originally envisioned with the Apollo program, and have more of a long-term presence on the moon. So it takes time to develop new technologies. It takes political will to make sure that the direction of the agency stays in one direction long enough so that we can actually accomplish some of these really challenging and amazing accomplishments. So missions, excuse me.
Yeah, excellent. Thank you very much, Jason. And with the Orion spacecraft, are you able to give us a little bit of a background into how long that's been around and what its use is?
Absolutely. So the Orion spacecraft has changed and evolved a little bit over the last decade. It was originally conceived in about 2008, but then there was a time when the program was actually briefly canceled, and then it was redone. And then our mission over time evolved from going to deep space to now we're focused on going back and forth to the moon. And we can carry 4 astronauts on board for 21 days in space by itself without needing any other spacecraft. So we are designed to conduct missions beyond low Earth orbit, so beyond the protection of Earth's magnetic field, where we know astronauts will be exposed to greater radiation. We are designed to spend more time in space so that the astronauts can conduct longer missions on the surface of the moon than what Apollo was able to. And if you're familiar with Apollo, you know that, and if you've seen the movie Apollo 13, you know we had 3 astronauts at a time. We will be able to split with 4 astronauts. And then the other major thing that we put in there is that we want to make sure that we can select among the entire population, so we support as large a range of people as we possibly can. And when I say that, I mean like short from about like 4'10" up until about a 6'5" person, which is something that most spacecraft usually were centered around kind of a 50th percent, an average height for a male. Now we're really trying to go from the smaller woman body size up to some of the larger male body sizes, so that we can open up this opportunity to explore to as wide a range of people as possible.
Yeah, thanks, Jason. Also, is there a particular age to be a crew member?
So there is no definite age. I mean, right now the oldest active astronaut in the astronaut corps is Don Pettit, and I believe he's 65 years old. And then, if you're familiar, John Glenn flew into space in his 70s. And then the youngest astronaut, I believe, is in their 20s. I don't know exactly their exact age, so we try to accommodate as wide a range as possible. Sometimes, when there are lots of stories from astronauts that you don't always get in on your first try. If it's something you want to do, you keep trying, and then you hopefully find your way to get your foot in the door. And it doesn't necessarily matter that you're in your 30s or 40s. There's still opportunities to make that dream happen.
Fantastic. And obviously there's only a few astronauts out of the amount of people that work at NASA. So one of the questions is, what are the main skills and qualities that are right across the organization? What sort of people are you looking for to work at NASA?
So obviously we need a lot of engineers. I myself have a mechanical engineering degree from college, Worcester Polytechnic Institute in Massachusetts. And we take lots of engineering disciplines. So I'm mechanical engineering. We have aerospace engineers, electrical engineers, computer engineers. But really, if you're interested in spaceflight, we take every skill set you can imagine. We have accountants, we have lawyers, we have publicists, we have seamstresses who sew up suits. We have videographers, we have camera experts, we have communications experts. It really takes every discipline that we need to make the world work. It takes to make the space program work. So if you love spaceflight and you have an interest, whatever your interest is, we can find a way to use that in our program. So
that's a really good answer. So it's work hard and a bit of curiosity, and there could be a role for you. A couple of questions here, and then I'll see if Rob's got some coming through from the students as well. We were reading about how the South Pole is going to be visited for the first time. It sounds really cold, so I just wondered if it is really cold and how it differs to other places where people have walked before.
What's interesting about it is in space, because you don't have the air to help manage heat and humidity and the atmosphere between you and the sun's radiation. It's actually really hot whenever you're in direct sunlight, and then it gets really cold whenever you go into the shade. Now, the lunar South Pole is a location that's being picked because we know that there's water ice below the surface, or at the surface on the lunar South Pole. And we really want to figure out if we can take that ice and we can use it for different things. Can we turn it into rocket fuel so that we can go farther into space for exploration? Can we turn it into oxygen that the astronauts could breathe with? Can we turn it into water in some form to help? And then there's a number of different uses, obviously, if we were able to do that. And the reason that that's important, one of the hardest things in spaceflight is getting there, and everything in spaceflight is very heavy, and so for as heavy as each thing is, you need that much thrust on your rocket. So if we can decrease the amount of stuff that we have to bring with us, that'll allow us to go further into the solar system for exploration. And so it's setting up camp at the lunar South Pole so that we can test these technologies and develop these concepts to be able to take this lunar ice and turn it into things like rocket fuel and oxygen will really set us up for further exploration to Mars and other destinations in the future.
Thanks, Jason. Robert, do you have any questions for Jason?
Just some of the questions from our coming in from our schools. Brad's asked a question: is staying on the moon a money saver? And I think you've partly sort of answered some of that as well, but is that the factor or part of the reason they've gone to that space?
It is hard to say it's a money saver, in that it is very expensive for us to do this, right? These are very difficult missions for us to execute. But what we're trying to do is have an architecture, and what I mean by that is our spacecraft, the lunar lander. We're developing lunar rovers that can then function for a longer period of time, so that we're not just flying a bunch of stuff out to the moon for one 14-day mission. We're going to fly things out to the moon. We're going to have a space station out there in lunar orbit called our Gateway Space Station, and then we will set up an infrastructure on the lunar surface for power, for communications, for a habitat that'll allow us to reuse that over time. So, the initial cost is high. The long-term cost going there permanently will eventually come down as we figure out really and implement these technologies. So, but it's certainly not cheap to start. It takes a lot of contributions from countries all over the world to make that happen.
Yep, well, that's kind of ties into our next question, which has come through. It says, is NASA going to be part of the Space Force?
So the Space Force is a U.S. military branch, and we are not a military operation. We are a civilian operation. Every now and then we do collaborations with the Space Force, and we actually work with the Space Force in some limited capacity. But we are completely civilian enterprise. Our mission is exploration, and we want to do that in partnership with countries around the world as we continue to set up this presence on the moon and go beyond that. So.
Excellent. Thank you, Jason. I think those are all the questions we've had so far. I just got one for myself, and I just wondered, and I always ask this when I chat to new people, about your job and about the work that you do. Do you have a really interesting fact that's always useful to share at parties or with family that you that you think might be really interesting for people to hear?
Boy, really interesting fact. That's a hard one. I will say one of the things, I know a lot of kids are interested in becoming an astronaut. One of the most important things about being an astronaut is that you have to be really healthy and you have to take care of yourself. There are things, and sometimes it's luck. And one thing that I tell people who are interested in an astronaut, your luck it may hold you back from that. Like, when astronauts are in space, they're more likely to develop a kidney stone, which is very painful. So people who have had kidney stones aren't allowed to be astronauts. And I had two. And so, okay, that dream was off the table for me, but there are thousands of roles here. And so even though I couldn't be an astronaut, I have a whole lot of things that I can do to help the space program and help us explore space. So I don't know if that meets your qualifications there for a really interesting factoid, but it's one thing that comes up a lot.
It was certainly something I didn't know before, so that counts in my book. Thank you for that.
All right.
Just got two more questions here, and one is, what is the relationship between weight and fuel?
That's a great question. There's a thrust to weight ratio that gets calculated for that, and it costs thousands of dollars a pound to lift something off from orbit. But it's been a long time since I did those calculations. I used to do that back when I was in college, but I haven't had to do that in about 20 years or so. So my knowledge on that one is a little bit rusty. But what I can say is that we are in a constant effort to decrease the weight of the things that we are launching into space so that we need less fuel. You may have heard about 6 years ago, I believe, actually maybe a little bit longer than that at this point, we flew our first inflatable structure to the International Space Station. And it was really just it's kind of a large balloon. And we flew it as an experiment to see how well would it hold up over time in the environment of low Earth orbit, with increased exposure to radiation, increased exposure to hazards such as something potentially hitting it and puncturing it, and it's functioned really well. And we will continue to explore those concepts. There's a company here that's pursuing setting up a commercial space station in low Earth orbit using inflatable structures, and then I'm sure we'll continue to explore them for our lunar space as well. Sorry, I can't answer the question directly, but it's a constant challenge for us to try to bring down mass of the spacecraft so that we can decrease the amount of propellant we need to get it to orbit.
Oh, thank you for that. And I'm conscious of time, so let me give you one final one. There's quite a few questions coming through, but this one has been asked a couple of times. It says, my understanding is no country can claim territory on the moon. So legally, who's in charge if there's a permanent base up there?
So the United States is entering into an agreement called the Artemis Accords that you may have heard of. And we're actually working with space agencies around the globe. And I believe we've approached Australia as well in recent months. I know we have agreements with the European Space Agency, the Japanese Space Agency, United Arab Emirates, where we are approaching this as a joint global effort with the United States, obviously, as a leading partner in this, with NASA's experience in spaceflight, trying to bring that forward to ensure that we're successful. But the fact remains that this is an expensive endeavor, and this is something where we want all the countries of the world that can come together and help us with this civil exploration of the moon. So, the United States will be the lead entity for at least our lunar South Pole efforts. China is actually developing their own concepts for lunar habitat, and they're working independently from us. And there are a number of other countries that are working in coordination with us.
Wow, thank you for that, Jason, and thanks so much for your time. We are going to leave it there because we've got to go and explore these wonderful worlds that you've helped design. Is there anything you want to just finish with that you haven't had a chance to say yet?
Sure. It is an extremely exciting time. I hope everybody has had a chance to see our mission videos. If you can access them on YouTube or other social media sites where you can see all the wonderful shots of us going around the moon. It'll be another couple of years. Right now, we're planning to launch Artemis 2 in 2024, and we just named our Artemis 2 crew members. Our astronauts were selected on Tuesday. So in just 2 short years, we will have returned people for the first time to the moon for the first time since 1972. And it is a privilege to be able to speak with you all. And I hope everybody enjoys. I did get a chance to help consult with the Minecraft team to help design some of their activities within Orion on this. So I'm excited that this is going out for everybody, and I hope all the students enjoy it. And I hope you get to enjoy the missions. And I look forward to working with some of you someday in the future here. So.
Thanks, Jason. Bye for now, and thanks for your time today.
My pleasure. Thank you.
So we'll put up some. We'll share the links to the videos and things that Jason has mentioned today. But what we're going to do now is we're going to kick on with today's activities. So what are we going to actually learn now? We're going to look at some coding puzzles in Minecraft, and we're going to look at some of the actual missions that Artemis 2 will be taking part in, and we will try and interact with that in Minecraft. This is an absolutely fantastic world that I'm really excited to go through with you today. There are a couple of ways that you can play these activities. You can work individually as an individual player, but you can also do teamwork as well, and we're going to try that later on. Me and Robert are going to try and work together on that. So what I'm going to do is I'm going to hand over to Robert in a minute to talk us through about how to log into the find the world and get started. So we'll be working as individuals or in teams, and we're going to complete a number of tasks. I don't think we'll have time to go through all of them today, but you may want to go through them by yourself or with your classmates if you're at school. So we're going to launch the Artemis rocket build. We're going to go into Minecraft Education. We're going to go into the library, search for Artemis, and we're looking for Artemis Return to the Moon. So we want to make sure we get the right world. So are you able to share your screen, Robert? And we can and Robert can walk you through the first couple of activities. Over to you, Robert.
Thank you, everyone. So I'm just in my login screen. So as soon as I'm in Minecraft Education, this is the screen we come up with. So if I click on our play button, that will take us into where we can find our different things. We're going to go to the View Library section here. And in here, right up the top, as Stephen said, if we click on Search Library and type in Artemis and search for it, it will come up with our 2 different Artemis missions. So the one we're doing is this second one here, the brand new one, as was mentioned a moment ago. So Artemis Return to the Moon. So if we click on that and we'll click Create World. Now it is a fairly big world that we're grabbing. So if you get that as soon as you can, it's going to download that world and import it. And then it's going to actually load directly into your game for you as well. Now, when you first start on this Minecraft Education game, it's a little bit different to a lot of the other games that you've got. So to begin with, you get this NPC and basically a bit of information here. And the NPCs are really there to tell you what's going on throughout your game. So make sure you read the information which is there. So in this case, it says, welcome to Return to the Moon. Before we blast off into space, we'll need to prepare you to ensure your crew is ready. To begin, use your device to either left click or press the control scheme that best applies to you. So for instance, in this case, if you're using a computer or a laptop, you would use the keyboard option. If you are using an iPad or any other sort of tablet, you would use the touch controls. Actually, that includes phones now as well, because we've got Minecraft Education on phones too. So anything like that, you can use the touch controls. I'm using a laptop, so I'm going to click on the keyboard option. Now, for today, in this case here, basically it's looking at the type of coding, because this is a coding lesson that we're doing today. So the coding language you can choose. You can either choose between block coding or Python coding. We're actually going to be using block coding for today. So if you wanted to do the same as us, if you click on the block coding, that's going to keep us all exactly the same. So basically, this is for people who are new to coding. In Australia, for us, it's a lot of our primary school students as well. Even though some of you may not be new to coding, we tend to focus in the block coding space in primary schools. So we're going to use make code blocks. So we'll click yes on that. And then it also gives you that bit of information that Stephen was mentioning before. If you want to play in multiplayer and don't know how, you can have a look through here, read how to do that, and then watch how to do that as well. So that will open up a browser window and show you that. Stephen and I will go through that once we actually get into playing, or once I've gone through a couple of missions individually first. So you do have to wait for till your entire crew has joined the game, and then you have to run your code. And I'll show you what we mean with that in just a moment, because as I said, it's not quite the same as a normal Minecraft game where you just jump in and start running around. So once everyone runs their code, then the journey can begin. So if I click got it, now in this case, I can actually only move my mouse up and down, or my screen up and down. You can see that I do have a message down the bottom of my screen that says press C to open code builder. So if I do that, this is where we actually start our game. So if I had more people that were joining, I would get them to join first, and then we would all be in the same game first, and then we could drag our code across to on start, where it says go for launch. And then when we click that play button, we would need to make sure that all players were ready to go. Because I'm just doing this one by myself, it's only me, I don't need to wait for anyone else. So as soon as I run that code, you can see that it goes to the next part of our actual game. And so this is our rocket taking off, and we've got the name of our mission as well. So this is now what's taking us into the actual spacecraft. So it says, what a ride. Did you know astronauts can feel up to 6 Gs of force during liftoff? So G-force is the measurement of acceleration. So G meaning gravity. So on Earth, you feel 1 G, which means in 6 Gs, your body feels 6 times heavier. So if I click on next, it goes through all of the different things that we need to do. So that's what our NPC is actually doing in this case. It's talking us through what we need to do. So you can show how to use your console on the Orion crew module. If this is your first mission in space, would you like that? So I'm going to click yes, and he's going to talk through what we've got there. So it says, great, let's begin by extending your console. Look left or right and interact with the blinking button to begin. If I click got it, I'm just going to talk about a little bit of stuff because it says look left or right. So I'll explain that to you, especially if you're in a multiplayer game. So when I click got it, you can see that I'm sitting over here and there's more space people over on the side there. So there's more people. There's one person below me, which you can just see their helmet. And I've got 2 people over to the right of me. And they're their consoles over here. And you can see that that's the console for the person below me. And this one here is my console. So see my flashing button there. If I click on that, it'll bring the console over. So you can see now that I'm interacting with the button later. And it'll retract our console. So it'll either pull it out in front of you or move it back away from you. So your main screen is where you can track your journey. The further along the Orion is, the closer you'll be to the end of the mission. So interact with the blinking button on the left screen when you're ready to proceed. So I'll show you where that is now. So you can see we've got an interacting, a flashing button here. So if I click on that button, it says this is your fidget screen. So you can use it for non-critical activities like checking your emails, turning your lights on and off, or chatting with friends. Now, to start a mission critical task, what we need to do is interact with one of the blinking buttons to the right. So if I jump over here, you can see that we've got blinking buttons over on the side here. And I've got 4 that are blinking on the side. So if I interact with one of those, it tells me what the objective of this mission is. So it's to get as many points as possible before my splashdown back to Earth. So be careful, you can only get one try to run your code on each mission. So there's only one chance to get it right. There is this trophy icon, which shows how many points your team will earn for completing that task. So don't worry if you're playing this game on your own, the computer will join the mission and help you. Some tasks require 2 members and special tasks will require the whole crew. This icon shows how many crew members are required to start the task. So you'll see as people join, it will fill up 1/4 of this square icon as it goes. So they'll shade in green as people join that particular thing. Below the main screen is your ready switch. I'll show you where that is in just a moment. And when you're ready to go, that's the one that you actually click on. So if we have a look here, first of all, that mission that I've clicked on, it's got that green there to show that I'm in there. You've got a 1 just on our little trophy there to show that it's going to give us 1 point, and we've got our flashing switch here. So that's our start switch. So that confirms that I do want to do that mission. If I wanted to change now, I could click on a different mission, and I can switch between those missions depending on what I wanted to do. Okay, but then when I've chosen my mission, I click on the confirm switch, and that will take me to the mission. So what I need to do here is mark 3 lunar landing sites. So there's going to be a little bit more information about this to tell me what's going to be a good lunar landing site. So it says we found 13 places near the moon's south pole where we might be able to land safely. The 3 places should be relatively flat, have good communication with Earth, and have lots of ice nearby. So use the probe to mark the landing sites. So once I've read that, I can go back and read the first page again just to check. But I've got this one, so I'm going to run through and see where we can go. So the first part is for me to have a look at my whole map that I've got here. So there are a couple of bits of information I needed to remember, is that it had to be somewhere relatively flat and it had to be close to ice. So you can see that this section here that's got the blocks stepping up there, that wouldn't be a good place because it's not very flat. I do have a flat space over here, but it's not close to any ice. So you can see that there's a couple of places here that might be really good because it's nice and flat and also close to ice. So as soon as I found a few places that I think would be good options, what I can do is I can press my C. It goes into my coding and it'll show me the coding blocks that I need. So if I drag this mark location block across and drop it into the on start, it shows that I've actually got coordinates here to mark a location. So you can see that the first coordinate is ABC and all the way through to L. And the second coordinate will be from 0 all the way to 9.
Well, hi Rob.
So
can I just ask you to? We can't actually see the coding blocks, so can we just close that and reopen it? See if that helps.
Yes, I will, and I'm hoping that doesn't just stay blank for you because it's dropping through to another site. Yeah. Give me a moment. Let me see if I can reshare my screen and just do it as a whole screen, and maybe that will help.
Yeah, give that a go. Otherwise, I've got it set up on mine as well. So
yeah,
just bear with us for a second. But might be a good time to pause, check where you're working at. If you've, I know sometimes students will rush ahead. If anyone's already done any of the activities, maybe you can let us know in the Q&A. But that looks like it's working now. Well done, Rob.
Yep. No, that's all right. Just had to give my whole screen there. Now, what I'm actually going to do first of all is I'm going to drop in 3 location markers because it did say that I needed 3 different sites. And you will notice if I close my code, I don't lose anything I've done, but I can have another look at my map. So my first spot that I'm going to choose is F and 1 because it's right next to this bit of ice here and it's a nice flat spot. So if I click C, I can go, my location will be F1, and now I can close that and go find a second location. So my second location was this one here, which was D5. So I'll press C again, jump back into here, and I'll choose D5. 5.
Excellent. Can I just pause there? What's really
Yeah.
cool is if you press those 3 little lines underneath the X,
Oh, yes.
you can flick the coding from side to side, so you can actually see what you're
move it
doing.
around
Yeah.
and get a bit closer. The one thing I found when I was doing that with this one is that if I flip it to this side, I can't see my numbers going down. So I did find that it was actually easier just to jump out here. Otherwise, it doesn't have the 1 to 9 down on the side over here. So, or
Yeah.
1 to 6. So what I needed to do was jump out and find an easier spot to find to land. So I might actually make my last one H1. But yeah, whichever way is going to work for you, you can either just look to the side or you can jump in and out of that code as well. So it does save any code you've done.
I guess it kind of depends on which activity you're doing.
Yes, yeah, definitely.
And sometimes you might want to maximize the coding window as well if you're doing something complicated.
Yep, so if you needed to make it a maximum, if you click that larger window, it goes across the whole page there for you. So it makes it a lot easier. All right, so I'm going to minimize that again first. So I've got my 3 locations that I want, which is what it's asked me to do. What I'm going to do now is click the play button, which will run my code, and that will tell me how I've gone with it. So if I click that, it's put it there and it says incomplete, and it must be because I'm using the same ice block on 2. We did not receive enough data from the probe to select landing sites. We will need to try again. And I would say it's probably because my last site was using the same ice block as the one previously. So I would have had to have chosen a different one. Perhaps if I chose this site down here, right next to that ice block, that's fairly flat, and that might have given me a positive outcome.
Also, I think that one you actually had the ice had to be on the actual block. So I think
no, I have done that one before, Stephen, and it was just right next to the ice, so and that was okay. So so yeah, that's that one there for you. Now you will notice that these do change as well as I go out of those and back in. So you can replay these several times because there's multiple different things that you can do. Have we still got time for me to do one more?
Yeah, let's look at one more and try really hard this time, Robert.
I will try my best. Okay, so I'm going to choose this one here. I haven't done this one before, so I am going to have to try really hard and think very carefully. So Earth's pollution is this one. So it says launch CubeSats over cities where you see large pollution clouds. One way to combat pollution is to understand the source of those pollutants and how they react with our atmosphere. Los Alamos National Laboratory has built a tiny satellite called the NanoSat Atmospheric Chemistry Hyperspectral Observation System, or NACHOS. NACHOS is a lot easier to say. So let's move on and we'll have a look at what NACHOS is doing. So we need to use NACHOS to get this important information about our atmosphere. So what we need to do is we need to find those places with a large amount of pollution. So we've got one there at B2, we've got another one there at E1, another one here at I1. And I think that looks like all of them. Can you see any that I'm missing there, Stephen?
No, I think this is a good thing to do as well. If you're working with, if you've got someone with you, someone next to you, is to just double check and make sure you're putting the coding. So let's try and remember those. I can see B2, E1 and I1. Yeah.
And usually I would be doing this and writing those down on a piece of paper right next to me, because that does also make life a whole lot easier as well. So in this case, we've only got deploy CubeSat. So let's go to our first one, which was B2. Our next one was E1. And I'm guessing the last one was I1 from memory, but we will check that before we run it. So there's E1 and I1. Oh, look at that, my memory does work.
Excellent.
Okay, so let's play that one. I'm feeling pretty confident about this one, Stephen, so let's see how we go. There we go. So you can see that it's put the probe over all of them. So the nachos data has been received and is being analysed by our scientists. Now you can see here that I've gotten my 1 point from doing that mission, and it's jumped up over on the side there. So it does show that my team, which is only me at the moment, is up over here, and I can have a look at what I've got. So
yeah, thanks, Rob. I just want to say something about nachos, because someone asked the question earlier about what we can learn on the moon about Earth, and I was reading about nachos. I'm not going to say the full name, but I was learning that it can actually help scientists learn about how air and volcanoes work on Earth as well. It's like a special camera that takes pictures and can actually show how that affects us on Earth. So I think that's a really exciting and so realistic, what we've just done in Minecraft.
Yeah, very. That's fantastic. All the data you can get from those spaces is great.
That's fantastic. I want to just see if you have clicked that question mark, because I'm curious as to what that does. Do you know?
This one here?
On the left,
that retracts. It retracts your console.
Did you see something happen out the window?
Oh,
Did you see something? Keep an eye on the window when you press that.
Oh. Okay.
You see a dolphin chasing a fish.
Must be a lunar dolphin.
Yeah, exactly, a lunar dolphin. That's I noticed that when I was playing it, and I thought that's a fun little Easter egg. So what's this telling us? So we're coming back to Earth.
It did give me a message that said that re-entry was in 1 minute, so I obviously took too long. So the quicker you go through these, the more time you get to actually go through different missions as well. But yes, it does give you a lot of extra playability because you can keep going through this for quite a while. You will notice anytime you go into these set screens that you can only move up and down on the screen, but you can't move side to side. So just be aware if you get into that, it's not a glitch. They've actually just changed it so you can't get out of that space there. So congratulations on your lunar journey. You're part of a new generation of explorers, astronauts, and visionaries, the Artemis generation. Your experiences as an astronaut are just the beginning. Keep your eyes towards the stars and keep dreaming big. And guys, I think as Jason said to you before, they are looking for a lot of people in this sort of space, whether you become an astronaut or whether you're part of the ground crew helping out as well. There are thousands of people that work in this space. So if you have that dream, you've got to dream big.
Excellent. Thanks, Robert. Are you should we try something together?
Let's give that a go. Do you want to start it, or did you want me to start it?
I'll start it. So I'll share my screen in, and then we can take it from there. Okay. Hopefully that's coming up now. Okay. So I expect people have already sussed out multiplayer. If you're playing by yourself, then you might want to skip this bit, but definitely worth doing if you have got a friend or a classmate. Always better to play together. And as we heard from Jason earlier, a lot of the activities that the crew will be doing do require teamwork. So Robert and I are going to try and work together to solve some problems. So what I'm going to do is open up the world, the same world that we've just been looking at, and I'm going to generate a code for Robert to type in or to click the pictures. I think many of you will have used multiplayer before, and hopefully he'll find my world and we will be able to play together. So what I'm going to do is I've just opened up the world and I'm in the same position as before where Rob was. And I don't want to go for launch until we're all in the same world. So what I'm going to do is pause the game by pressing escape. I'm on a Windows computer here, and I'm going to generate a code. Okay, so my code, I'll read it out. is map, Alex, balloon, potion. So what Robert needs to do, rather than go and find the world, he's just going to go and join a world and click those pictures. And if I resume the game, if Robert is successful, it will let me know when he's joined the game. And you can have 1, 2, 3, or 4 players playing this world together. How's it going, Robert? Hi, Robert. You seem to have frozen. Are you with me?
I'm back now. Everything just disappeared. So it wasn't coming up with your world, and when I closed Minecraft, it closed everything.
So that often
right.
happens. So let me share the join code again. Should we give it one last try?
Yep.
So I've just put the join code there. It's map, Alex, balloon, potion.
No, it says does not match any worlds that are currently available.
Oh,
all right. Which is
maybe
a shame.
Let me actually close that and restart right from the beginning. We'll just we'll try once more because it's totally fun to be able to play with someone else. So bear with us. If you've had success with multiplayer, let us know in the Q&A. But otherwise, I'm just going to try this once more. And see how we go. This worked so well when we were practicing the other day.
We had no issues at all with the practice. It's always the way, though.
Here we go. Yeah, I'll reload the world. So I'm going to go to View Library and search for Artemis. We had a question earlier about the cost of rockets. If you go into the other Artemis mission, Artemis rocket build, you can find out all about what it takes to build a rocket, both financially and all of the science behind it as well. But of course, this is what we're looking at today. So I'm going to create the world. It might be because I created it too soon, but we'll see how we go this time. If not, I can do a couple of activities. What's really nice is if you don't have a partner to play with, the computer will actually take the role of an artificial intelligence crew member and do part of the activity for you. So you can still play the 2-player games, even if you're just one person working at home or working at school by yourself. So we'll give this another try. Yeah, it's a fairly big world. It's got to download all of the scientific equipment that we're going to be using, plus all of the coding resources and computers in the background. So it takes a little while to get loaded, but hopefully it's all going to be worth it and we'll be able to collaborate together. Now, I don't know how far we are in kilometers or miles from each other, but I'm on the west coast of Australia and Robert's on the east coast, so thousands of kilometers away. But let's give this a try. Yep, got it. So I'm going to generate a code. Fingers crossed. This time it is fish, book and quill, pickaxe.
Nope, didn't work again. It's that same join error issue.
Okay, well, what I'll do,
well.
what I'll do is I'll just press on by myself, and please chip in with any hints or tips as we go through. But before you can do any of the 2-player activities, you have to do the 1-player ones as well. So I'll play along. It might be because we're distance-wise so far away from each other, but I reckon we can do this together. So normally, if you had multiple people playing, they would all join the same world, and then they would all click this code, go for launch, and then we're ready to go. So we're just going to do exactly the same again, but I'll show you some of the 2-player ones as well. So here we go. I love the graphics in this. Is this one of the best designed worlds you've seen in Minecraft, Robert?
It is just fantastic. It's a very, very well developed world, this one. So I do like the little touches, even that takeoff that you get. It's very nicely made.
Absolutely. I won't look at the consoles because I've done that before. I'm going to go straight into the activities. So I think altogether there's 14 different activities. There's single player ones. I think there's 8 of those. There's a few 2-player ones and then 4-player ones as well. So I'll just choose one of these. Let's try and choose one we haven't done before. That looks new to me. Is that new to you?
Yeah, I have not done that one before.
Let's see if we can do this between us. Asteroid mining. This looks fun. Collect a mineral sample from the asteroid. They may contain rare earth metals such as gold. I guess another word for rare might be valuable. Collect a mineral sample from the asteroid. Okay, got it. So I guess that's my sample collector. So I've just got to find my way there. If I pull that over to the left-hand side of the screen, I should be able to do it without closing the code builder window. Let's try this. So I'll have a go. What I think it is, and you say whether you're happy with that before I run it. How about that, Robert?
That sounds like a plan. I'll look at debugging if there's any issues.
I'm using my finger to count across, and I reckon it's 1 across, 3 down, and then 1 across. Okay, so use the rover move. Yep, so rover move right by 1, down by 3, and then right by 1. Another shortcut here is I can right click on one of these if I'm using a mouse, and I can duplicate it. So that just saves me a couple of clicks. And then I've obviously got to mine the asteroid at the end. If I'm sharing this, maybe I'm a teacher sharing with a class, I can make that larger so people can see it. Or I can make it smaller if I need to fit more on the screen. What do you think of my coding?
Now, I didn't see you change it there, but on the down, did you change that to 3 down? It's only a very small window for me.
Yes, I've put move it down by 0.
That's lucky we checked.
There we go. I'd be mining without moving, which is not what I want to do. So that's right. Let's try that, or we agree on that.
Yep.
Complete. The probe sensors detected large amounts of gold as well as trace amounts of nickel and iron. Amazing. I thought there'd be gold there.
Mm-hmm.
It definitely looked like it. Okay, and so this is keeping track of my score. So I've done 1. Shall I just see what my friend has to say?
I think so.
The screen above shows the amount of points your entire crew has earned so far. Excellent. So it would be the same if you were in the world with me. We'd have that same number shared between us. And
if I had done my own single player mission that I succeeded in, we could have had 2 points there.
Excellent. What do you think this button does? It's
that's your light.
So
there you
probably
go.
Won't have, there we go. That's nice. I can see what's going on out there now. So I can have my 4 crew members all working on their own individual missions. But because I've completed a mission, it's now opened the 2-player missions. So shall we go and have a look at one of those?
I think so.
That looks like a little buggy, and that looks like some kind of drill. Do you fancy buggy or drill?
I think I've done the drill one once before, so let's try the buggy one.
Yeah, try a new one. Excellent. Oh, so this is worth 3 points if we do this.
That's not
Now,
bad.
the way these are set up is that one person does part of the activity, and then the second person does the second part. But I think the way this works is that the computer automatically does the first part for me. So it says mark 3 locations on the south pole of the moon and navigate Viper. And Viper is it's a special robot to actually look for ice on the moon. So there was an unmanned mission, uncrewed mission, a robot that discovered what looked like water. So they're going to go and find out about that, and it's also going to be able to see how the surface of the moon has changed over time. So that's actually landing next year. So when the crew that Jason was talking about go to the moon, they're going to circle the moon and send the Viper down, and it's going to stay there for, I think, 100 days. And then it's going to be joined by humans on the moon in 2025. So very exciting. Oh, it's all that information is there, but I've already told you that. And what's great is my computer pal has already marked the 3 places where I'm going to drill. So I'll imagine that you did that, Robert. Thanks for that.
No problem at all.
They look like good places to drill. So I think all I need to do is take the samples. So I've got the easy part of the job here. Loading the blocks in the background. Your partner has marked the 3 locations. We've done that. So all I need to do is take a picture. So do I need to actually move or not?
I think you're going to have to mark the locations and take a picture after.
I think they've been marked by my artificial intelligence crew member. So I think I just need to take a picture. Let me try it.
Oh, you only get one go though, remember? So I think you'll have to put the coordinates of where you need to take a picture at. So maybe move to the coordinates first and then take a picture and then do coordinates and then a picture.
There's nothing to move. So I think that because they've already been marked, I'm going to give it a go.
Okay.
If I'm wrong, we can try another one. But it's always I think because you've already done that for me, I just need to take the picture, but I'm not sure. Let's give it a go. Always worth trying these things. We can always restart the whole game if we need
That's
to.
it.
Oh, incomplete. I don't know. We did not receive the data we were hoping for. We'll try again later. Oh, sorry. I couldn't see what I needed to move.
No, sometimes I think when it has the coordinate maps, you just have to put the coordinates in and it marks them as either correct or incorrect. Whereas the other ones, you've got the code, the agent that you're moving around in the world. Okay. So they're just 2 different types or 2 different styles that I've come across so far.
We're going to have to try this one much more carefully. Let's try one more.
Righto.
And if I fail this, I'm going to have to pass the mouse to you. Rehydrate the ingredients. That's it. I think, like I said, there's 14 or 14 activities, and I hadn't done them all, and that was one I hadn't done. Whoops. Rehydrate the ingredients and build pizzas for the crew. Oh, this sounds fun. Always like a pizza challenge. Cooking food in space is different than on Earth. Space food is freeze-dried to store and preserve it. Astronauts rehydrate the food by adding water to their meal packs. Team up with a partner to make the meal. One of you will rehydrate the ingredients, the other will build the pizzas your crew wants to eat. Okay, we can do this. So something's happening. So I guess that's my my imaginary teammate has just done something, and now I've got to find out what I need to do. I think we can work this one out. Have you done this activity, Robert?
No, I have not done this one at all. So I'm going to be very little help on this one, I would presume.
Okay.
So let's see what sort of code we've got, and that might give us a clue.
Absolutely. Once your partner finishes rehydrating the tomato sauce, it's your turn. So I think that's what has just happened, hasn't it? So use the add block to add all the ingredients the crew wants, and then use the serve pizza block. The pizza should have the following ingredients. So let's I'm going to make this larger so we can actually see that, and then we can be well, not 100%, but near 100% sure. So we need to add tomato sauce. So I'm guessing that is that one.
Yep.
Then I'm going to add cheese. Oh no, that's pepperoni, isn't it? I would think. Tomato. That's a tomato. Yeah.
Yeah. Yep.
Oh, very small.
Say nothing comes up when you hover over it.
No. So you've got to use your eyes. Ah, dear. That's why I think making the screen bigger and zooming in helped a little bit. Okay. I ran out of time.
Unlucky.
I wondered why it wasn't working. We got quite far. We did a few of the activities there. Is it gonna give me an end of game message? Did you see how many points we'd actually got there?
I think it was still only one because we missed out on the points on that second one.
Oh, of course. But we're still part of a new generation, and your experience as an astronaut are just the beginning. So this is the same. I got the rank of astronaut. So I'm just going to show you. I can get a certificate or I can replay. So what I'm going to do is just bring up a couple of things here. We tried multiplayer, and I have given, it's going too fast there. I've given a certificate of completion for you, Robert. So I will put that in an email and send it on to you for successful completion of Artemis Return to the Moon. Because there is, while you might not have success in an individual activity, you always have some success. So there's actually 4 ranks of expert that you can become. So we only made it to astronaut today in our first try. So if you get 0 to 8, you're an astronaut. 9 to 21, you're a veteran. 22 to 23, you're an expert. And 34 or more, you're an expert plus. So I think to get to 34 or more, I think you definitely need a team of 4 people that are good at problem solving.
I think so. With the amount of time you've got, because it is only a limited time game, so that the time it could be a big factor overall there.
Absolutely. So I think that's really worth bearing in mind. So it would be great to hear from those people who have been playing. You can maybe just put into the Q&A if you finished. What score did you get? Is there a school that's joined us today who's managed to become an expert or an expert plus? I think I definitely need a bit more practice.
Yeah, me too.
So I'd keen to know what your favourite part of today's lesson was. So if you'd like to share that in the Q&A, that would be really, really nice for us to know when we run other activities like that. Just let us know what your favourite part of today's lesson was. Robert, what did you enjoy most of today's lesson?
I think my favourite part of the lesson today was talking to Jason. He's a wealth of knowledge, and it's great to meet someone who's actually working with the NASA team to make all of this change happen.
Yeah, absolutely. And I love the fact that he actually consulted on the Minecraft build to make it look accurate and realistic for what people actually do. So that's a really good point.
Yeah.
I also want to just share, I've got some reflection questions here. We're not going to go through these right now, but if you're watching this on the video, or you'd like to pause the screen and maybe go through these with your friends and classmates, have a think about your favorite mission that you did, and did you learn about some of these terms? We've mentioned some of these. Jason was talking about the Orion, which is the program he works on. Robert and I were looking at the Viper and Nachos when we were doing the activities. So it'd be great just for you to reflect on what you've done today. So if you want to do have more fun, there are some really great activities online. I'll put the link in the chat. The Challenger activities, there's 6 lessons where you can go and explore more about what NASA does in a Minecraft environment. So do check those out. Do check out the other Artemis world, the building a rocket that I briefly showed you earlier. And I believe there's another NASA world coming as well, another Artemis world that's being built, so you'll be able to have a look at that. But I'd really like to just say thank you so much for coming along today. Thanks to Jason for joining us from NASA and sharing all his knowledge and experiences with us. Thanks so much to Robert for joining in and driving the activities for us, and thanks to all the students and teachers who've joined in today. So keep exploring, keep being curious, and thanks so much for joining us.
Thank you. Thanks, everyone, and thanks, Stephen, for organising this. It's been a great lesson.
Cheers. Bye-bye.